In this video, I would like to talk about our first topic of the semester, R vectors. And let me start by saying something that this is me. I like to think of R as a vector-based language. So R is a vector-based language. So what do I mean by this? Well, by this, I mean that the most fundamental type or most fundamental object or data structure in R are vectors. So let me draw here a diagram. There are two flavors, two big classes of vectors. On one hand, we have what it's called atomic vectors. And then, of course, on the other hand, we have what it's called non-atomic vectors. So these would be the two main flavors of vectors. And then pretty much any other data object, at least native data object in R, are gonna be built on top of vectors. So with atomic vectors, there are four main types. And one of them, or the most basic one, we could say that it's logical. Then, of course, you have integer vectors. Then we have double or real vectors. So I'm going to write down here within parentheses sort of a synonym, double real vectors. And then finally, character vectors. So these are our four, again, main types of atomic vectors. R has sort of a historical component in terms of considering both integer as well as double. It considers them to be numeric. So there is sort of a subclass or a subset of atomic type, which is numeric. So to give you examples, very minimalist examples, logical, we have two main values, true and false. And this is the way you write them in R, everything in uppercase letters. There is also NA, which stands for missing values. It's actually not available. Technically, that's the meaning of the acronym, not available. And we use them to encode missing values. By default, this is kind of like the plain vanilla missing value type, can be considered to be logical. Integers. R uses a very special notation. If you want to declare, or if you want to specify, for example, number 1 to be an integer, you need to append an uppercase L next to it. For example, if I want to do the same thing for 100 encoded as integer, I also need to append capital L. There is a specific missing values for integers. They all start with NA underscore integer, and then you need to include an extra underscore at the end. Double real numbers by default, any number that you type in, for example, 1 or 100 or 2.37, everything is by default stored as double or real values. It also has available a missing value specific for real numbers, and this is NA underscore real underscore at the end. Then we also have character or a string. So I'm just going to write in parentheses a string, that the way most people know them from other programming languages. And again, the idea is to type in a name and surrounded by either double quotes, or you could also use single quotes. Just whatever type of quote you use at the beginning, that's the one you use to match the closing type of quote. There are two additional data types. These are less common, very specific to R. One of them is called the raw data type, and the other one is for complex numbers. So for complex numbers, just to give you an example, you could do something like 2 plus 2 and the imaginary part with lowercase I. And then raw, this is essentially a binary format in R. I don't really use these guys, by the way. This obviously depends on what you are doing. I've been using R for more than a decade, and I haven't had a need to use them, but I'm just telling you, these are also available in case you need them. A little bit about properties of R. I've already told you the main data types. The way I like to think of vectors or picture in my mind vectors is something like this. For example, let's say we have an object X that I'm going to declare as a vector. One way to create vectors is with the combine or catenate function. This is just lowercase c. Say I'm going to create a vector with these three numbers, 2, 4, and 6, separated by commas. So the mental picture, so to speak, with this idea of contiguous cells, it's something like this. So R will internally store X with 3 contiguous cells of data containing the values that we specified, 2, 4, and 6. Important comments, the way R indexes positions, it always starts at position number 1 and then 2 and 3 in this case. So just be careful, starting position, this is always 1. Compared to other programming languages where you may start indexing at 0, R, you need to start indexing at 1. Vectors have a data type. There is a very useful, convenient function called type of, and type of will give you the data type of a given vector, whether it's logical or integer or double or character, or maybe raw or complex. So the type of a vector, another important property is the length of a vector, and there's also the corresponding function length that it will give you the, let me call it the size, how many elements, how many things a vector stores. And then in addition, this is sort of optional, you could also specify additional attributes of a vector. For example, you could give names to a vector. So this is just an example. Let me take vector X here, and we could assign names to it with the function names. And I'm going to do something simple. So let me assign a name, letter A for the first element, letter B or character B for the second element, and character C for the third element. So what this is doing, so to speak, is, again, in pictures, you have your vector X with 2, 4, and 6, and R will have associated names for the elements of this guy. So this is an example. The attribute in this case of X, the attribute would be names. It has length 3, and it would be of type double. Let's also talk about the notion of implicit coercion. And the way I like to think of this as, it's as a set of rules, implicit coercion rules. The main idea, I'm going to show this to you in tabular format. The idea of implicit coercion rules has to do with this question of how R behaves, or what happens when you try to combine, or when you combine different data types into a single vector. And the answer to this question comes dictated by the implicit coercion rules. If you mix one logical value with another logical value inside a vector, the resulting data type will also be logical. Now, if you mix a logical value with an integer value, integer will dominate, so everything will be coerced into integers. Logical and double will dominate, so everything will be coerced, converted into double. And finally, logical and character, everything will be converted into characters. And then let me move to the next row. Integers and logical, same idea. Integers will prevail. Integer and integer, this will result in an integer. Integer and double, double has a larger priority, hierarchy, and then integer and character, this will be character. I'm just going to abbreviate it like this. Double and logical, So you're going to get double. And I hope you can see an interesting pattern over here with this table. And then finally, character mixed with anything else will always result into characters. So what I'm trying to do with this table is depict sort of the rules that R will implicitly apply. And you can see this pattern, this hierarchy of data types. And let me also include that here. The hierarchy of data types will be as follows. Logical has kind of like the lowest importance, and then you have integer, and then you have double, and finally character. So if you try to mix, same data types will result in same data type. If you try to mix two or more different data types, these will dictate what happens. Say you have a vector, let me call this vector A, with the combine function, and let's say that you want to combine a logical value true with an integer value 1. Well, in this case, right, so this is logical, this is integer, integer will dominate, and the resulting data type of A will be integer. Or for example, let's say you have an integer 2 with a double value 2. So notice here the uppercase L next to 2 in the first element. The resulting data type of this guy will be double. And let's do one more example. Let's say I call a vector D, and then in this guy, let's say I combine a logical value false, a integer 5, and then a double 5, and finally a character 5 in letters, in strings. So because I have this character, everything else will be coerced into character data. We also have the complement operation, explicit coercion. And here's not so much rules, but this actually has to do with a set of functions that will allow you to explicitly sort of like take control over the default behavior in R and force R to treat certain vectors with a specific data type. These functions, they all have the same format. They always start with AS, so as dot, and then you just specify the data type that you want to use, as dot logical, as dot integer, as dot double, and so on and so forth. So let me also include as dot character. So these guys allow you to convert things. Another short example. So let's say I would like to as logical. Let me apply logical, right? So then R will convert, or will leave true as true, and then the integer value will try to convert it into logical. Sometimes that's possible, sometimes it's not. In this case, it is possible. So again, you can use the explicit coercion functions.